Welcome and hello. This is a video exercise using HEC ResSim, and I'm titling this exercise Flood Control. I'm going to route a hydrograph through a reservoir. It's going to cause a flood, and then we're going to implement a few strategies to mitigate that flood. Okay, so I have HEC ResSim version 3.3 up here on the screen. I'm in my watershed setup module, and we're going to begin by creating a watershed. Okay, so uh, go ahead and enter your name, the directory, and then this metadata, like a time zone and units, and click OK. The watershed directory and its associated files have been set up. Let's go ahead and start the editing process. I'm just going to go ahead and sketch a stream alignment here. Stream 1, OK. Now let's go ahead and add our reservoir. Let's first add a computation point, CP1. This will be a junction in our network. And then a reservoir. I'm just going to hold down control, single left click, let go of control, and then another left click. Reservoir 1, that's going to actually add a couple of computation points, and then one downstream computation point for good measure. Hold down control, single left click on the stream alignment, and CP4 is good. All right. Now I'm going to go ahead and create a configuration. Time step of 1 hour. Okay. Apply and okay. That's good for the watershed setup module. I'm going to quickly file save watershed and then head over to the reservoir network module. Network new, network 1. And then that will be based on the configuration we just created. Okay, so that brings in our junctions and the reservoir. I'm going to go ahead and add the reach to connect the network. So I click on the reach tool here, hold down control, single left click on the junction, and then let go of control, left click on the next junction. I will just accept the default reach name it gives me here, and then do the same thing for the reach that's downstream of the reservoir. Okay, let's save our network, and we are ready to add stuff. So let's begin by adding the inflow to the upstreammost junction on our network, and this is junction CP1. Right click, edit junction properties, and then click the local flow tab here. It's the second tab. I'll just call it inflow at CP1 with a multiply factor of 1, so we're not multiplying it by anything. Okay. Next, let's edit the reservoir. Right click, edit reservoir properties. What I have is a pool and a dam. I like to rename the dam to just dam to keep it simple. And then let's edit the geometry of the reservoir first by clicking on pool. Okay, I'm going to paste in the pool geometry and then click apply. And then the plots show up here on the right. That's all I need to do there. Over in the dam, I'm going to right click and then add a controlled outlet. Okay, so paste it in those numbers for a controlled outlet. We'll just go with one single gate. So the max capacity of outflow is 5,500 CFS. And that's when the reservoir is at an elevation of the top 1,500, as we can confirm by the pool elevation here. All right, going to click apply and now head over to the operations tab. I'm going to select operations new and create a new operation set, and then OK. These are the 3 zones that automatically were created. That's fine. I'm going to just work with those. So I'm going to set the top elevation of the flood control zone as the top of the reservoir. Apply. Okay. And then for conservation, we'll say it's 1450 feet. Apply. And then inactive will be 1350 feet. Apply. So these are our 3 zones, and the conservation zone is currently identified as the guide curve. Okay, back on the physical tab, I wanted to not forget to put the dam elevation of 1,500, and I'll make up a dam length, we'll say 1,200 feet. Okay, that's good for that. Let's go ahead and create an alternative. Edit. Actually, hold on. Before creating an alternative, I want to create the hydrograph, which will serve as our inflow up here at CP1. So I'm going to just peek at the reservoir properties one more time. And the outflow, again, is from 0 to 5,500 CFS. So if I make up, I want the peak flow of my hydrograph to be larger than 5,500 CFS. All right, so let's go ahead and go Tools, HEC DSS View. And then here I'm going to, let's create a file, time series data.dss. It's in my watershed directory. That's okay. And now I'm going to go data entry, manual time series. So I'm going to enter time series data in here myself. I'll just be generic with these path name parts and call it river, location, flow for the project, location, and the parameter. It's going to be a 1 hour flow. Let's do this for the month of May 2024. So it's going to be a 1 month duration of the simulation, but the time interval here is going to be 1 hour. We'll just call it H. And then we'll start on the first hour of the month. That is May 2024. The units will be in CFS. Instantaneous value. Yeah, I could either use that or period average. We'll just stick with instantaneous value. Okay, I've got some values saved on my clipboard, so I'm going to paste them in here and then click save. And then no, I don't need to see the editor. Oops, those are my values there from Excel. And then let's go ahead and take a look at those values. So this is what we're looking at here on a time series. We have a base flow of 1000 CFS. And then we have this hydrograph that occurs from May 4th to May 7th with a peak about 2100 CFS. So that's what we're looking at there. We could double check some of the math functions here by clicking math functions and then statistics. So the peak flow is 21,698 for that particular uh, time series data set. Okay, so I close that for now. Let's go ahead and add that alternative one that we want to start with here. So alternative new, we'll go with alt one based on network one. Looks good. Our time step is going to be 1 hour. And then we'll leave all the other settings the same as default here. Operation set one. The look back is going to be, we're going to start with the elevation in the reservoir pool equal to the guide curve elevation, which is 1450. That's the top of the conservation zone. And then the release, we're going to start at 1000 CFS because that's the base flow that'll be coming in all month. So I figured that's a pretty good steady state. And the time series, we'll go ahead and select that hydrograph that we just created. I have to navigate to the file real quick. Here we are. Okay. Okay. And then set path name. So when I click that set path name, that entered that data set, or it linked it from the file name and the file path into my alternative. Okay. So let me save the alternative and then close. Now we're ready to save the network. And then let's go over to the simulation module. And we need to go simulation new. We'll name the simulation 1 and then add the date time. So this will be May 2024. I'm going to start it on May 2nd, but the look back period is going to be a day before on May 1st. So that's what I'm doing here. And the simulation is going to end at the end of the month, which will be May 31st. And then, yeah, noon works. So we'll go ahead and select alternative one, click OK, and we're ready to compute. So click compute and close. Let's take a look at what happens at this reservoir. Okay, I got the reservoir plot on the screen. And what we can tell is that this top plot is the water surface elevation and the reservoir pool. And you can see that it starts at the guide curve elevation of 1450, and then it goes up, and it doesn't quite even spill over the top of the dam, the 1500-foot elevation mark. So it comes close, but it doesn't spill completely. And you can see that the outlet is flowing. That's the green line here in this bottom plot is the release from the controlled outlet. And sure enough, it looks like it gets close to its maximum of 5,500 right here when the water surface elevation of the pool is near 1,500 feet. So what I want to do in this exercise is to make the water spill over the top of the reservoir. So I think one easy way to do that is to just use a hydrograph with more water. So let's go ahead and do that and then come back to look at this plot and observe some spill happening. I'm going to go back to my HEC DSS view and create a second hydrograph with more flow. So let me go over to my file that I created the first time here. Okay. And I'm just going to duplicate this. I'm going to call it H2. Okay. Okay. So we have H and we have H2. Let me go ahead and edit those values. So here are the values I need to edit. Control V will paste numbers in. I mean, I can show you the numbers, but it's easier to just show the plot. So let me click save here. And then those are the numbers from Excel I copied in. Here is the hydrograph. And you can see it's basically a same base flow of 1,000 CFS, but now the peak is up to about 46,000 CFS. So this is a much more water than we had before flowing into our network at CP1 and then downstream into our reservoir 1. So let's go ahead and create a second alternative, which will now use that second hydrograph. Alternative, edit, then let's go with alternative. Oops, sorry, I forgot. So I need to switch the module to reservoir network. That allows me to create new alternatives, edit alternatives, and delete alternatives. Alternative, new, alt 2. Okay. I'm going to leave pretty much everything the same except for that time series. So this is the same. Operation set 1. The look back data is going to again start at 1450 and start with releasing 1000 CFS. Now the time series is going to be H2. Hold on one second. I'm going to go to DSS view and copy that hydrograph I created over into the DSS file that I think ResSim is going to be reading from the simulation 1. So let me open up, that's the source. Now I got to find the target.dss file. That is right here, I believe, open. Okay. So I'm going to copy by going over to the source, identifying H2, edit, copy to. I'm not sure if this is a bug, but it's a little bit inconvenient. And then simulation 1 and then simulation.dss open, which is really a copy. Okay. I think we're good here. Let me go back to the alternative editor and just make sure that this time series is referencing the time series in this simulation directory. Okay, and then I'll just filter to H2. There it is. I think that's good. Okay, let's click alternative and then save and then close that. All right, let's go back to the simulation and add alternative 2 to our simulation 1 and then go ahead and compute. Let's set as active first and compute alternative 2. All right, let's go ahead and right click on the reservoir and then click plot. And this looks much better. Looks like we have significant spill over that 1,500-foot line. I'm not sure how trustable this information is because we didn't give reservoir geometry above 1,500, but I'm going to highlight that green line. This represents the water surface elevation in the reservoir for the month of May based on all the inputs that we gave it. And then down below, you can see that the hydrograph, again, is reaching up to 46,000 CFS. And the controlled outlet in dark green down here is flowing at pretty much full capacity for like 11 or 12 days. So that's what we want. Now, what I want to do is go ahead and use a few strategies. I have 3 strategies in mind in this exercise I want to employ to keep this water surface elevation below 1,500. The first one is going to be alternative 3, and that will be to change the guide curve leading up to the storm. So we know that there's a storm coming, there's a hydrograph that like a lot of water on its way, and we want to reduce the water in the reservoir. So what that's going to look like is I'll head over to the reservoir network module and then right click on the edit reservoir properties. operations tab, and conservation is the zone identified as our guide curve zone. And right now it's just 1450, but on, say, at the beginning of the simulation period, I could say it's May 1, and then we could drop that down to 1400. And then if I click apply, that's a little weird looking. Let me define the December 31st day. Okay, so I defined December 31 as 1400 feet again, and that kept it down for the rest of the year. All right, so let's go ahead and see how that works. Click OK. I'm going to save the network, and then I'm going to create a new alternative. This will be alternative 3. All the information will be the same as alternative 2 here. Save that alternative. Okay, close. Save the network. I think I already did that. And then simulation tab. Let's go ahead and add alternative 3 and run it. See what happens. Set as active and compute alt 3. Close. All right, so right click on the plot. And this looks a lot like alternative 2. In fact, let me show the plot for alternative 2 and alternative 3 together so we can see what the difference is. Okay, I made the plot bigger, and as you can see, the alternative 2 is the green line, and then when we reduce the guide curve elevation to 1400, it was there's a little difference, but not a huge difference. That didn't do much for me in this situation. But you can see that the guide curve really is working, because right when the simulation begins at noon on May 2, the water surface elevation starts decreasing. Very little mitigation by that particular strategy in this situation. And I just think that's partially because the reservoir doesn't have enough storage to release, enough water to release, as well as enough time. Little, too late on this one. All right, so I'm going to go and create an alternative 4. This is going to be flood control strategy number 2. I'm going to add a second outlet with the same parameters, a second controlled outlet, and then keep everything else the same. So the guide curve, the hydrograph, everything else. So I'm going to close the plot, head over to the reservoir network module. Sure, save the simulation. And then we're going to right click on the reservoir and click edit reservoir properties. Head over to the physical tab, and then in controlled outlet, right now I just have one gate right here. So if I hit 2, then it's going to double my max capacity. So I'll go ahead and click apply. And then we will close out of this and then save the network. And then I'm going to go ahead and create alternative 4 now. This is going to be alternative new, alternative 4. All right, let's go ahead and save that alternative. Then save the network. Okay, head back over to the simulation module, then add our alternative 4. Okay, we'll set that as the active alternative, and then we can right click compute. Okay, all right, let's take a look at the plot. And it looks like we're getting better. In fact, let me go ahead and bring up the same plot with alternative 3. So right click, plot, and hide the legend here. Okay, we can see much improvement by adding a second controlled outlet gate. Alternative 3 is in green, and then alternative 4 with the second outlet is in red, where at the beginning of the simulation, the reservoir elevation drops down quicker towards the guide curve, and then we can see there's more release during the hydrograph period right here, because the red line is above the green line. So I assume that's the double amount. We can see that the reservoir elevation guide curve is achieved much sooner for the red line with 2 outlet structures compared to 1, where there's only one controlled outlet gate. All right, so right click to zoom out. There's one more thing. Obviously, we haven't achieved our goals yet. We could have added a third controlled outlet gate, and that would probably suffice. But I want to do something different. I want to add a diversion to the upstream junction and then see what that does. So one last time, we'll go back to the reservoir network module. Yes, and I'm going to click on the diversion tool and then hold down control and then single left click on that CP1, or I could have done CP2, and then I'll just click off to the side. This will be an unconnected diversion. Let's call it diversion 1. Okay, let's go ahead and right click on the diversion and then edit diversion properties. Now we could just put like a constant flow, but I think it makes more sense to make it based on a flow function or the pool elevation. Yeah, so let's go ahead and do pool elevation. Okay, I'm going to go ahead and type in some numbers here. So 1450, we'll say there's 0 diversion, but when the reservoir pool is at the top, which is 1500, we'll say the diversion is 20,000 CFS. I'm just making up numbers here. This probably isn't too realistic, but let's just see what happens. I'm going to go ahead and click apply and then save the network. Now let's add an alternative 5 here. 5, okay. And then as just like alternative 3 and 4, I'm going to type in the same data here. Okay, for look back period, we also have to define the initial diversion. That's going to be 0 because our initial elevation has always been 1450. We said that an elevation of 1450 in the reservoir pool would result in a 0 CFS diversion. Okay, and then the initial release would again be 1000. Okay, so the alternative has been saved. We're going to go over to the simulation module one last time here. We'll add alternative 5 now and click OK. I'm going to set that one active and then click compute. Alrighty, drum roll please, right click and plot. And it looks like we are good. So I made the plot full screen here for me. And what I'm seeing is that the water surface elevation here drops down from 1450 almost down to the guide curve elevation of 1400. And then based on the diversion flow, as well as the controlled outlet gates, that the reservoir is now able to keep that huge inflow hydrograph from spilling over the 1500-foot elevation mark. Down below, we have our inflow hydrograph. And remember, this is for the reservoir. So we don't have as large of a peak anymore because it used to be like 46,000 CFS, but the upstream diversion is taking care of part of that. It looks like it's closer to like 36,000. And then this green line here represents the release through the controlled outlets. So right when the simulation starts, it releases a bunch of water to try to attain that guide curve elevation up here. And then once the inflow hydrograph arrives at the reservoir, those two controlled outlet gates continue spilling. That's all I had prepared for this exercise. We looked at an inflow hydrograph into a reservoir and then did 3 separate strategies to mitigate the floodwaters, which was to modify the guide curve. Secondly, was to increase the outflow capacity through the controlled outlets. And then thirdly was to add an upstream diversion. Let's actually go ahead and right click and check out that plot for the diversion. Yep, sure enough, it was active and flowing from basically May 5th through May 7th or 8th, and that looks good. All right, well, that's it for this exercise.